Okay. So, good afternoon. Thank you so much for attending this community meeting. I am going to talk about ODD specifications, and I think that those of you who use TEI Publisher are very familiar with the part of the auto specification that is related to the TEI processing model. But here we are going to focus on schema generation. I will begin by presenting what is ODD. And although I think most of you have at least a notion of what it is, and then I would like to talk about the importance of schemas in the context of interoperability and reusability. Then I would like to introduce a bit the notion of TEI conformance and what actually it entails. And then I think the part more interesting of the presentation is in the one where we discuss good practices when writing auto specifications and the different resources we have available for processing them. So ODD stands for one document does it all, and this is the definition we have in the TEI guidelines. It's a TEI XML format that is used to express schema fragments and also the documentation in just one document. And this is how the TEI P5 is actually defined. And it's also the format we use to create schema, TEI schema customizations. ODD looks like this, for instance. Through the ODD, we express what elements of the TEI we are using. So for instance, in this case, we are specifying which models we are going to use. And at the same time, we are saying which parts of the TEI we are not using. Like for instance, by naming the elements that belong to that model, but that they are not going to be included in our final schema. At the same time, we can also use it to create constraints, to define constraints. In this case, imagining that this is a schema for correspondence, we are creating a constraint for the element profile desk, in which we are changing its content, and we are making mandatory the element correct description, right? Correct desk. So this is what a ODD does, specifying which elements we use, which elements we don't, and creating constraints. And also we write the documentation of these constraints, and we could do many other things like add new elements, or for instance, providing examples for our colleagues that are going to encode and use this documentation as guidelines for encoding. Just by using TEI, we are not interoperable, and we are not making easy for others to use our data set. This depends on the existence of a good schema. And to make my point, I wanted to show you how many elements are available in TEI. But then I thought that I will get my point across much better if instead I show how many elements are possible children of just P. So just paragraph in the TEI complete schema. So for instance, TEI all has 208 possible children besides the text node, right? So this is obviously a hindrance for interoperability. If you are curious now, TEI has 586 elements and 270 attributes with a distinct name, which is not exactly as different attributes, but it's a nuance we are not discussing here. And this is in the current version of TEI. We are making a release next week, and I'm happy to announce that there will be 1 new element and I think 2 new attributes. So this list will be even higher next week. And so this is why it's so important to have documentation and to have schema specifications. They are going to control the consistency, the homogeneity of our encoding, and they are going to document the data model in the sense that this model corresponds exactly to the real informational requirements of our project. So I really doubt that there is any project out there that requires 208 possible elements as children of paragraph. And it's thanks to this, to a schema that we are actually increasing the usability of our data set. Not only for others, but also for ourselves. We are going to be able to exploit it much better or easier and with much more efficiency if we guarantee that we know how to retrieve the different elements or attributes, the different phenomena, because we know that a specific phenomenon is always encoded the same way. And it's also useful when we are using tools, TEI tools that are out there, and they usually have certain expectations about our data model or how we are doing the modeling. And as I said before, it's also crucial for reusability. Those who want to use our data set should not have to open 100 documents to see how we are encoding the stuff. They should be able to open the documentation and get the idea of what the data model is. And then there is the matter of interoperability. With 208 possible elements of P, or the 587 total elements of TEI, it's very hard to actually be interoperable. It's thanks to the constraints that we are able to actually implement this type of interoperability. Then about TEI conformance. What is TEI conformance besides promises we make in grant applications? According to the guidelines, there is a very specific definition of what being TEI conformant entails, and it requires to have a well-formed XML document that can be validated against a TEI schema, that conforms to the TEI abstract model, that uses namespaces correctly, and that is documented by means of a TEI conformant auth file, which refers to the TEI guidelines. So actually having an auth, it's a requirement for being TEI conformant. And concerning the second point of the schema, that it has to validate against a TEI schema, there is also some requirements about how this schema needs to be created. And the schema file needs to be derived from the published TEI guidelines, combined and documented in the manner described in the section customization, which explains how auth works. And so also the generation of the schema needs to go through auth for it to be TEI conformant. And thankfully for all of us, there are many customizations already out there that we can use. So many occasions we don't need to do them ourselves. I will share the slides in the Slack channel or maybe in the website, so you all have access to the different URLs and links that I mentioned in the slides. So here there is a very minimum list with examples of customizations. The first two are provided by the TEI consortium. the last two are provided by the TEI community. So the first one I mentioned, the TEI Lite, it's supposed to meet 90% of the needs of 90% of the TEI user community. And according to the TEI website, it's the most used TEI customization. Personally, I doubt this claim, and I do think that maybe TEI All is the most used TEI customization, even though it was never meant to be used in real projects, and it was just so for testing reasons to have the whole TEI data set. It was never meant for actual use in projects. And there is also TEI simple prints for the needs of early modern printed material, particularly for the Western European tradition. And then for libraries, there is these best practices for TEI in libraries that includes odds and different pieces of documentation. And also, as an example, TEI Lex 0, which is meant for encoding machine readable dictionaries. So these are just a few examples of customizations that exist out there and that we could use. Within this actual community, there is also the initiative to create a customization for the community to use, and we might know about it more soon. So for the part concerning the good practices, I was thinking about doing these do's and don'ts as in the title, but my don't list only have the do not use TEI All as an item. So I decided to speak about good practices in a more general way. So one of the things I will start by is to think who are the audience of our odds. And this audience is actually very heterogeneous. On the one hand, we are writing our odds for ourselves, for the project members, for the researchers, so they can document the different decisions. They can write down the rationale of certain choices, and also to keep track of the different changes that take place during the history of the project. A note is also a guideline for the encoders, so for the people who are doing the annotation, and it should work as a reference guide for them. So examples or borderline cases or certain specific phenomena should be exemplified in the odds. And they are also done for the odds are also written for the developers, because here we have the description of the data model, and we are telling them what needs to be expected. And so they can write, so they can do an actual implementation of the data set. So for instance, here is the place where we know how which different elements are being used, or different combination of elements and attributes for presenting italics. It's not the first time that working with projects, we find that, for instance, the rent attribute has as possible values I for italics, but also the word italic for italics, and also the word italics for italics. So this type of variants are usually avoided thanks to a schema, and this will be homogenized under just one form that will be explained here for the developers. And so this will be the audience within our own project, but there is also the external audience, which will be the scientific community in general. And here we have those people who are interested in creating interoperable data sets. And for instance, if I am encoding, I have corpus of the 1970 or 70th century Portuguese theater, and somebody else is doing a similar corpus in a different language, and they want to make comparisons between both data sets. So they might use our schema to do their own encoding, because that way they will know that with the same data model, it will be much more easier to do comparisons. And anybody else using the data set probably maybe to enhance it and add other different layers of annotation also are going to use the use the documentation for knowing the data model. And we also should think of the customization as part of the data, which means that where the data goes, the customization goes as well. So they should always be shared at the same time. And as a good practice, the auth should be associated to a specific release of the TEI, and we can do that in using the source attribute, either in the schema spec to declare that the complete schema depends on, for instance, version 4.7, or we could also do it just for specific elements that are associated to a specific version. And considering that the TEI is that the guidelines are continuously being updated, it's very important to consider versioning when we are writing auth customizations. And there are different strategies. I think this is the easier one. There are other scholars who prefer to read the release notes every time that there is a release, usually twice per year, to know what is different, and then make the necessary adjustments in their auths for that. But even if we do it like this, when the project is over and we are not doing any more updates, the final version of the auth should always be associated to a TEI version, because this is what is going to guarantee that our data is valuable and that is reusable and along the years, because we always know to against which what we have to use, what TEI source we have to use to recompose the schemas and the documentation. And finally, the auth should always document the current encoding practice. So there are different ways to represent in the documentation how something has been done before or at a certain point, but the current practice should always be the one being defined. Then I would like to talk about auth chaining. Is not a best practice as to say everybody should do chaining. It's just to call this strategy to your attention and tease out certain advantages. For those of you who use TEI Publisher, it's very likely that you are familiar with the concept of chaining already, because if you have developed your own auth, is very, very likely that you are using the TEI Publisher auth as source. And so this is what chaining entails, that you have a customization of a previous customization. And you can do this process as many times as you want. So a possible workflow is to do the state of the art, to know what customizations are out there that are related to the needs of your own project. For instance, it could be like the TEI Lex 0 I mentioned before for dictionaries, or EpiDoc, about which we had a talk 2 weeks ago. And EpiDoc is actually a very good example. It's a subset of TEI, originally meant for the encoding of epigraphic sources, but it has been extended, and other type of supports are also encoded using EpiDoc, like papyrus and codex, right? So this means that even though it's a subset of the TEI, it's actually quite flexible and rare and quite large. So it could be perfectly normal to do a derived auth that is based on EpiDoc. And in our derived auth, we only have to add constraints to the EpiDoc customization. So to make it, for instance, to adapt it just to the type of sources we are encoding, right? So this will be an option. This will also facilitate those who are familiar with EpiDoc to know exactly what are the differences in your schema. And at the same time, you are still interoperable with EpiDoc, but you are facilitating your encoding and the consistency of your project. And another strategy is to use chaining within the same project. And this can be done due to different reasons. It could be for separation of concerns or to increase the interoperability. Here I present different projects that use this technique, like the LTEC, this large corpus, multilingual corpus of European literature. They have a source auth and then different derived auths. In Humboldt Digital, they also use chaining, and it's this is particularly useful for projects in which different type of documents are being encoded. So you can have a source auth for all the documents, and then depending on the genre, you have a specific auth for letters or for correspondence, a specific auth for travel journals, for instance. And another example will be could be this Betamasa, which is for manuscripts of Ethiopia and Eritrea. And here they use chaining, but the chaining is done the other way around. The source auth, it's much more specific with more constraints than the derived auth, because the source auth is the one that they use for encoding their own documents, and the derived auth, in which some of the constraints are deleted, it's for, or made more flexible, it's for sharing the data, and I think introducing data from other resources. And I think this is my last point concerning the good practices, is to check for URIs and validate the URIs. It's very common that in our encoding projects, we have references in the text that point to a canonical reference or to a register, to an index. And if we later want to retrieve all the mentions of those entities, we need that the URI, we need for the URI to be correct. And thanks to schematron, which we can use in the auth, we can do this type of, we can formalize this type of verification. So we can check that the URI actually exists, for instance, in the register file. And we can also check that it's pointing to the correct type of element. So for instance, if I have in my text name type person with a ref attribute, I can check that is pointing to a XML ID in a person element in the register file. So this is something that we can do with auth. And here I present an example taken from this tutorial that is also mentioned in the list of tutorials made by Sid Bowman. And here we have a constraint spec, so a constriction that is added to the definition of the element G. And the type of verification we are doing, it's for special characters that are encoded with the G element. We are checking that the ref attribute is pointing to either a card element or a glyph element for character or glyph that is usually declared in the header of the document. So this is how we make sure that when we want to resolve this reference and present the actual character or the the character that we want to use is being the pointing is doing correctly. Okay, so now let's talk about the different resources we have for processing the auths. One of them is likely known by many of you. It's the web service Roma that provides a very intuitive interface for writing the auth itself, and then to generate the documentation and the schemas from it. It's personally, I find it very useful to for creating a very rough first draft of the auth and selecting the modules I am using, already taking out some elements, and then I download the auth and usually make some edition of the XML file manually, and then generate the schemas from it. But you could obviously create a schema auth completely in Roma. It's just that there are certain features that I find easier to do manually. And Roma also comes as a command line util, and so usually for separating it's called Roma with lowercase r. And then we also have, and it has the same functionalities as in Roma for the generation of the schemas, but it doesn't have the interface, so it's not going to be as useful, I think. Then we have TEI Garage, which is also a web service that enables the conversion from and to TEI from different formats. So this also includes the generation of HTML for the documentation, or the relaxing G schemas from the auth files. And TEI Garage also has an API, which can be also very useful. And both Roma and the TEI Garage, what they have under the hood is what is called the TEI style sheets, which is a set of XSLT style sheets. And this can also be downloaded and installed in your local machines, and it has a series of scripts that you can also use to do the conversions and the command line is the commands are very intuitive. They are usually called something like TEI to relax ng, and then the input file. And if you want, you can also express the output file, declare the output file. So it's very straightforward. And for those who use Oxygen, there is also the possibility to run transformation scenarios directly in Oxygen when you have an odd file, and get the schemas and the documentation from them. But the version of the guidelines that they are using depend on the version of the Oxygen you have. So the TEI Council also releases this plugin for Oxygen that enables you to have the last version of the guidelines in Oxygen, even if your Oxygen version is out of date. Then there is also ATOP, which is the task force Wolfgang mentioned in when he was presenting me. It's trying to rewrite the part of the style sheets that concern the generation of the schemas. At this point, there is already some code that can be used, but is not completely functional. But soon, hopefully. And besides using these tools locally to create our schemas, we can also use them in workflows that allow us to have a validation system and the generation of the schemas automatically every time we do a update to our auth. So here there are two examples of projects that have defined a workflow in GitHub. And mostly in both cases, so there are some differences, but what they are doing is that every time a change in the auth is done, a validation of the auth file is fired to be sure that the change is correct, that the schemas generated from it are regenerated due to the changes, and that they are also valid. And we could also do a complete validation of the data set with the new schemas. So all these different tasks of the workflow can be done by using some of the resources we have mentioned before. For instance, in the first one, they use the style sheets, and in the second one, there is calls to the TEI Garage API. So they use different strategies for the generation of the schemas. But this type of workflows are extremely useful for any project. So I encourage you to try them. And then concerning tutorials, there are quite a few out there. If I were to start, I will begin by this one done by the Women Writers Project. They have multiple resources for teaching and learning TEI, and in particularly the TEI customization primer is a great introduction to auths. Then there is the Getting Started with P5 auths done by the TEI Council. And in the resource TEI by example, there is also a module concerning auths. And then for advanced learners, there is this tutorial by Lou for the chaining, for auth chaining, and the tutorial I mentioned by Sid for checking the URIs. And I also provide some bibliography. And this was the original title of my presentation, because I wanted to sing praises to writing TEI customizations. Then I thought that the pun was very corny and I changed the title, but I hope I have transmitted to you the importance of the auto specification and some suggestions on how to write better documentation and better schemas. So thank you very much. And if there are any questions.